Chapter 8, Number 28. A 1.40 kilogram block slides with a speed of 0.950 meters per second on a frictionless horizontal surface until it encounters a spring with a force constant of 734 newtons per meter. So we have, to draw a picture really quickly, we have something like this, and there's a spring here, and the spring is hit by a box, or block, which is moving at some initial speed beforehand, and the spring has some spring constant that we know. And we're going to state this is like a wall, so the spring can't move out of the way. If the spring are free to move, then it's just going to move. So we'll assume there's a wall there forcing it to compress, and they want us to find the potential energy U, the kinetic energy K, and the total mechanical energy of the system for various compressions. And the very first thing we're going to see is there are no non-conservative forces acting because it is a frictionless horizontal surface. So the total energy is going to be constant, and I'm only going to find it once. I'm going to find the initial total energy, which is going to be the initial kinetic energy. So 1/2 times the mass, which is 1.40 kilograms, times the initial speed, 0.940 meters per second square, or we do all of that stuff, we get 0.63175 joules, which, based on our stuff, is really 3 digits, or 0.632 joules. And I'm not going to find that for any other parts because we know it will be constant. All right, and then they say find the potential energy and kinetic energy for compressions of whatever. So we're going to use the fact that the spring energy is 1/2 K times the compression squared. And we're just going to do a chart, and we're going to say then that the kinetic energy plus the potential energy is the energy of the whole system. So the kinetic energy is going to be E minus U. And then we would just do a chart. We'd say we'd have the compression U and K for all 5 parts. And it is just really plug and chug at this point, so we just grind that out. Just doing a fair bit of work in the calculator, we end up with the numbers that are shown here, which at least seem consistent because we're down to very little energy, kinetic energy at the end. It's not going to go much further, and it's only supposed to go 0.15 centimeters further. So it at least seems consistent.